Welcome to the DIY Honda Garage channel. Welcome to our diagnostic guide on DTC P0533, which indicates that there's an issue with the AC pressure sensor circuit registering high voltage. This code is pertinent to the Honda CR-V models from 2017 to 2022. The AC pressure sensor's main function is to monitor the refrigerant pressure within the air conditioning system and relay that information to the engine control module, ECM. The sensor is located in the AC compressor area, usually mounted on the line that connects the compressor to the condenser. It's crucial for the efficient functioning of the AC system, as it helps in preventing overpressure situations that could damage the system. Without proper function, the vehicle may not be able to maintain optimal cooling, impacting passenger comfort as well as the lifespan of the AC components. Let's dive deeper into understanding the error and the steps to resolve it. The AC pressure sensor is crucial in functioning efficiently within the vehicle's air conditioning system. Its primary role is to detect the pressure of the refrigerant flowing through the AC system. By providing this data, it allows the engine control module, ECM, to make necessary adjustments to ensure optimal cooling performance. The AC pressure sensor is typically located on the line connecting the compressor to the condenser, making it easily accessible for diagnosis and replacement. When the sensor reads a high voltage, such as what you would see with DTC P0533, it can indicate a potential fault, either with the sensor itself or its wiring. Anomalies in this reading may not only hinder the AC system's performance, but can also lead to further complications within the vehicle if not addressed in time. Diagnosing this issue properly relies heavily on understanding the relationship between the sensor's voltage and its performance. When diagnosing DTC P0533, several potential causes could lead to the high voltage reading in the AC pressure sensor circuit. First, a faulty AC pressure sensor itself may be producing erratic or incorrect voltage readings. This component is fundamental, as it directly influences the AC system's operation and can malfunction for various reasons, including wear and tear or physical damage. Secondly, bad wiring connections play a significant role. Poor connections, frays, or breaks in the wiring can lead to incorrect signals being sent to the engine control module, ECM. Lastly, malfunctions in the powertrain control module, PCM, which manages various engine and transmission functions, could also be at fault. In some instances, an issue in the PCM may misinterpret the input from the AC pressure sensor, leading to erroneous DTC codes. To effectively address this code, understanding these possible issues is essential. Identifying symptoms associated with DTC P0533 can aid in determining the severity of the situation. One major symptom is inadequate cooling from the AC system. This may manifest as the air conditioning not providing the desired temperature, which can affect passenger comfort significantly. Additionally, an increase in engine load could occur because the AC system is working harder than necessary due to incorrect pressure readings, possibly straining the vehicle's resources. Furthermore, there may be noticeably erratic AC performance, leading to situations where the system cycles on and off more frequently than usual. These symptoms highlight the importance of taking immediate action upon receiving the DTC P0533 code, because neglecting these issues could lead to more severe damages, both to the AC system and the overall vehicle performance. In the initial troubleshooting step for DTC P0533, the objective is to verify the presence of the error. Begin by starting the engine and allowing it to idle for a few moments, ensuring that its operating conditions are stable. Next, turn on the blower switch alongside the AC system to engage the air conditioning process. Utilizing the Honda Diagnostics system, HDS. Measure the parameters of the AC pressure sensor. Specifically, focus on whether the voltage exceeds the threshold of 4.75 volts, which indicates the circuit's operational state. If the measured value matches or exceeds this threshold, it confirms that the failure is duplicated, and you can move on to the next step. However, if the conditions do not match, this suggests an intermittent failure, and further examination of potential issues, such as poor connections or loose terminals, is warranted. Paying attention to the diagnostic data recorded during this check is crucial for reproducing the failure when necessary. In this second troubleshooting step, the focus shifts towards assessing the AC pressure sensor for potential failure. Begin by turning the vehicle to off or lock mode, allowing systems to reset. Next, disconnect the AC pressure sensor 3P connector to isolate it from the circuit. To create a controlled test environment, connect terminals A and B of the sensor's 3P connector with a jumper wire. Once this connection is established, switch the vehicle to on mode to supply power to the circuit. With the HDS, measure the voltage of the AC pressure sensor once again. You should find that the voltage exceeds 4.75 volts, similar to the previous steps. If the current condition meets this threshold, it narrows down the failure area to another component, and you can proceed to step 3. However, if it does not match, replacing the AC pressure sensor is essential to resolve the high voltage reading issue. Next, in troubleshooting step 3, the objective is to further isolate the issue by assessing the wiring and connections in the circuit. Begin by ensuring the vehicle is off or in lock mode to ensure safety during the test. Remove the jumper wire previously connected to the AC pressure sensor 3P connector. Once the sensor is disconnected, turn the vehicle to on mode, preparing to measure voltage levels. At this point, measure the voltage between the designated test points noted in the diagnostic information. These measurements must be taken carefully, as they help determine if sufficient voltage, around 5.0 volts, is available at the circuit. If the readings indicate a near 5.0 volts, then the wiring appears intact, and you can proceed to the next troubleshooting step. If the values differ significantly, it suggests a more profound issue, requiring further examination of the wires and their integrity. Moving on to troubleshooting step 4, emphasis is placed on validating the integrity of the PD sensor wire. Begin this segment by ensuring that the vehicle is off and in lock mode. Utilize the HDS to jump the SCS line, which temporarily shorts the system to facilitate diagnosis. After waiting for over a minute, disconnect the PCM connector A, which has 51 pins, to analyze this component's connection. The next vital step involves checking for continuity between specific test points, ensuring the wiring between the AC pressure sensor and the PCM is intact. Perform the test with the AC pressure sensor 3P connector disconnected and the PCM connector also detached. If continuity is present between the test points, it indicates the PD sensor wire is functioning correctly. In that event, it's advisable to check authorized service information or consider substituting with a known good PCM for further diagnosis. If continuity is absent, an open wire repair is necessary to address the issue, ensuring proper signal transmission to avoid further errors. The final step in the troubleshooting sequence focuses on evaluating the integrity of the SG6 wire. As with previous steps, ensure the vehicle is in off or lock mode. Confirm the short circuit in the SCS line beforehand using the HDS, and wait for over a minute to allow systems to stabilize. Once ready, proceed to disconnect the PCM connector A, again with 51 pins, preparing to check the critical continuity between test points. With the AC pressure sensor 3P connector disconnected, you will need to measure continuity between specified test points. If the continuity test between these points passes successfully, it's a good indication that the SG6 wire is operating properly and concludes the wire checks for this diagnostic sequence. In this case, referring to authorized service information regarding the DTCs or symptoms may be pragmatic, or opting for a known good PCM could assist in pinpointing further issues. Should continuity fail, an open wire repair is mandatory to maintain proper circuit function and resolve the DTC. At this stage, performing a final repair verification is crucial to ensure that the issue has been appropriately addressed. Initially, evaluate if the symptoms associated with DTC P0533, such as inadequate AC performance, have been rectified. After the repair, it's advisable to verify the operation of the AC pressure sensor, ensuring that it accurately reflects the refrigerant pressure. Once confirmed, proceed to clear the DTC from the vehicle's onboard computer system to refresh its operational state. Following clearance, conduct a road test to assess the air conditioning system under various conditions to confirm that the repairs effectively resolved the initial concerns. An accurate verification process ensures all components work harmoniously together and that no further discrepancies are present. It also enhances overall vehicle performance, ensuring a pleasant driving experience for passengers. While troubleshooting DTC P0533 assists in resolving immediate issues, implementing preventive maintenance can mitigate future problems. Evaluating the AC system regularly is a proactive measure, allowing for early detection of potential malfunctions before they escalate into serious faults. Periodic checks on electrical connections associated with the AC pressure sensor help identify any signs of wear, corrosion, or loose terminals that could lead to erroneous voltage readings. Furthermore, monitoring the sensor's performance consistently ensures that it remains operative and provides accurate data, thus safeguarding against triggering malfunction codes unnecessarily. These preventive steps not only extend the life of the AC components, but also enhance overall vehicle reliability, offering passengers the comfort and functionality expected from their Honda CR-V. In summary, DTC P0533 represents a crucial issue concerning the AC pressure sensor circuit, specifically indicating high voltage presence. Thoroughly understanding the role of the AC pressure sensor and associated wiring facilitates effective troubleshooting. Through systematic steps outlined, including verifying fault conditions, disconnecting components, measuring voltages, and checking continuity, one can effectively address this trouble code. Completing the necessary repairs involves not only fixing the fault, but also ensuring the AC system's efficient operations post-repair. Furthermore, adopting preventive maintenance strategies will greatly enhance the longevity and performance of the vehicle's climate control system. By following these guidelines, Honda CR-V owners can enjoy consistent performance and comfort in their vehicles for years to come. Please like and subscribe to the channel. See you next time.